All right, Unit 4, Section 6, coordinate proofs for parallelograms. This is it for all of Unit 4. So right here at the top, I have a list of all the ways that we can prove that a quadrilateral is a parallelogram. We listed those in the last video. So here is how a coordinate proof works. You're given 4 points, you need to plot them. They're here. I'm going to make them a little bit darker. Hopefully there's no questions on plotting points, but if there are, please talk to me. We'll get you caught up here. So there's our parallelogram. Now maybe what makes these hard is that we have 6 possible options here. I could show that opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, one pair of opposite sides are congruent and parallel, and then 2 pairs of angles. Generally, I want to avoid the angles. You be my guess if you want. It's doable, but it's probably a little more work than the rest. And the diagonals would bisect each other. So looking at this example, like I said, you can literally go any of those 6 ways if you want. For me, though, I'm going to choose this 4th option here. I'm going to show that one side is parallel, or one pair of opposite sides are parallel, and they are also congruent. They're the same length. So I'm going to actually look at BC, starting there. Okay, the slope of that line, if you count rise over run, is, well, if I start at B and I'm trying to work to C, I go up or down 0, so I rise none, and I run 1, 2, 3, 4, 5, 6. So my slope for, I should probably put BC here just so I know. My slope for BC is 0 over 6 or 0. Okay? So that means that the slope of AD would have to be 0 if this is a parallelogram. So we'll see here. So AD, goodness. Let's count rise over run again. So I'm going from A to D. I go up or down 0. And I run 1, 2, 3, 4, 5, 6 again. So therefore my slope is 0. So that means that BC is parallel to AD. If they have the same slope, they are parallel. Perfect. Okay. Now the distance from B to C, the length of BC is 1, 2, 3, 4, 5, 6. So BC equals 6. That means that AD is 1, 2, 3, 4, 5, 6. Equals 6. So, because I showed that one single pair, they're both parallel because they have a slope of 0, and they're congruent because they're both 6, this is a parallelogram. And that, I mean, you could have, like I said, you could have chosen any one of those 6 options and just kind of ran with it. For this one, let's just plot A, B, C, D on the grid. Well, I left it on there for you. So here they are, A, B, C, and D. So we're looking here, there, and there. So there's my parallelogram. Now, they've gone through and drawn the diagonals in there so that you could go ahead and show that one if you want. But again, the last 2 to me are going to be a little more work than probably the other ones. So let's maybe choose a different route. Let's show the opposite sides are parallel. That sounds like a really good option to me. I'm trying to make a star here. It's not really working. There we go, kind of. So, to show opposite sides parallel, again, we need to count slope. So, the slope of, I'll just do this. Slope of AB. So, we're going to count rise over run. So, start at A. We're going to go up 1, 2, 3, 4, 5, 6. We're going to run 1, 2. So my slope of AB is 3 if you simplify. So that means that the slope of DC will hopefully be 3 as well. Excuse me. So same thing. Count, I'm going to erase this quick. Count rise over run. So we're going to go 1, 2, 3, 4, 5, 6 over 2. And it's also 3. So again, I'm going to erase that quick because otherwise I'm going to have lines going everywhere. So that means that these lines are parallel because they have the same slope. Now, that's not enough on its own. I need to show that both pairs of opposite sides are parallel. So that also means I need to show that BC and AD are parallel. So let's start with BC. So let's go here. We'll count rise over run. So this time I have to go down 1, 2. So -2 over 1, 2, 3, 4, 5, 6, 7, 8. -2 over 8 is -1/4. So hopefully the slope of AD will be the same. If it's the same, then I showed opposite sides are parallel, and therefore I have a parallelogram. So I'll start at A. I have to go down 2 again, and over 1, 2, 3, 4, 5, 6, 7, 8. And who would have guessed? Because the opposite sides are parallel, we have a parallelogram. So let's draw those markings in there. There we go. And I have my work kind of off to the side here. I show that the slopes of the first two are the same. AB and DC, the opposite sides, are parallel, and BC and AD are parallel. And that's it.